Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one's entitled Earth Becoming Like Venus, Emits UV and X-rays from Atmosphere. Now, Planet X's and stellar cores, as well as their debris surrounded in water cloud envelopes, continue to come into the Earth's atmosphere in ever-increasing numbers and absorbing energy from the Earth. And you may look at Article 587 entitled Planet X Debris Filling Earth's Orbit and Streaming into the Earth for more details. The process through which they absorb energy starts with light or photons in the atmosphere. Light is emitted by the sun's simulators, but the Earth's surface also emits light, infrared light, which we human beings do not detect, but which can also begin the energy absorption process, although it would be much slower, as infrared photons have much lower energy than visible light photons. And this is illustrated in this diagram, this process. We start with photons moving through the Earth's atmosphere. The electron in the atom that makes up the cloud envelope will end up, these outer electrons will end up absorbing some of these photons. And when that happens, immediately the energy is shared with the nucleus, because the electron and the nucleus are connected through the gravitational interaction. So some of this photon energy, which is actually gravitational photon energy, because it's related to the gravitational interaction, is immediately shared between the two. And then what happens is, because the interaction between protons and electrons is actually repulsive, this electron, which now has a little bit of gravitational energy in it, and the nucleus has gained some as well, it now is ejected from the atom. It leaves the atom. That leaves an empty slot there. Then what happens is there are electrons in the Earth's atmosphere, and these electrons have photons inside them, and depending on the altitude, they will have more or less. The higher the altitude, the more energy they will have inside them, or most of them will have more energy inside them. We always have electrons that have higher energy moving upwards through the lower energy layers. Then, so this electron then enters, but in order to settle into that energy level, it has to release a photon. So it releases a photon. And if this electron was an ultraviolet electron, in other words, it had enough energy to release an ultraviolet photon, then it most likely released an ultraviolet photon when it settled into that orbit for this atom, that energy level. So that means that this atom would have emitted an ultraviolet light. So if the electron had been an X-ray photon, then the atom would have emitted an X-ray photon. A lower energy photon, like an infrared photon, may not give the electron enough energy to leave the atom, and it may move to a higher energy level instead, from where it may then leave after absorbing another photon, which suggests that photon energy is additive. In other words, two photons combine to become a photon of a higher energy. Once an electron moves to a higher energy level, it leaves behind an empty slot into which an electron from the atmosphere may go into and release excess energy as a photon. If the atom is at the right altitude, that photon may be an ultraviolet or an X-ray photon. This is because electrons occupy energy levels, and their gravitational photon energy increases with altitude. So electrons are repelled by the core due to the charge separation part of the gravitational interaction, and the ones with the largest amount of gravitational energy are repelled the furthest from the core and thus end up at the highest altitude. And this diagram illustrates the electrostatic and the gravitational interactions, which always oppose each other. So that protons, I always draw them as red because they're positively charged, and electrons are negatively charged. And in the electrostatic interaction, they attract each other. That's why we have arrows pointing to each other. this proton is attracted towards the electron. So the arrow means it's moving towards it, and the electron's trying to move towards the proton. It's attracted to it. Whilst in the gravitational interaction, the opposite occurs. And I call this the charge separation interaction as well, because this is what causes charge to be separate in the universe, in an atom. Otherwise, under the electrostatic interaction, these would combine and they would become a neutron. So it's the gravitational interaction, the charge separation part, that keeps charges apart in the universe. And that's because the proton and the electron now repel each other. And the strength of the interaction is dependent on the gravitational energy inside each particle. And the magnitude of the force is dependent on the mass and the strength of the gravitational interaction. So because two protons are much more massive than for the interaction with a proton and electron, because the electron is about 2,000 times less massive than a proton, the magnitude of the forces between the two protons is much stronger than the magnitude of the force between a proton and an electron. And this diagram illustrates what our atmosphere looks like. So we have Earth, and we have energy levels, electron energy levels, where the electron gravitational potential increases as we move upwards in altitude. So we get infrared electrons inside the Earth's surface and just above the Earth's surface, and that's why the Earth's surface emits infrared radiation. And then we have, a little above that, we have visible light electrons, and this is where our blue sky will be created in this layer. And then we have ultraviolet electrons, and then we have X-ray electrons right at the top. So, but matter, or the atmosphere, is much denser at the bottom than at the top. However, as the Earth loses gravitational energy because of the Planet X system absorbing it, these electron energy levels move downwards into the denser part of the atmosphere. And that means that the atmosphere will emit more and more ultraviolet and X-ray photons. So as stellar cores move down through the atmosphere, their cloud envelopes will absorb electrons and thus emit radiation specific to that altitude. This is why Earth's atmosphere is emitting more and more ultraviolet radiation, and it will also be emitting more and more X-ray radiation. In addition, as Earth loses gravitational energy, the electron levels move downwards to lower altitudes where there is more and more matter, especially Planet X matter, stellar cores and debris. So the Earth's atmosphere will emit increasing amounts of high energy radiation. When there is more radiation in the atmosphere due to all the stellar core cloud envelopes emitting radiation, and because there's just a denser atmosphere at that altitude, the atmosphere absorbs more radiation and thus becomes hotter. And so this means that the atmosphere will become increasingly hot as the electron energy levels drop down in altitude, eventually making the Earth's atmosphere into a superheated inferno. And I already discussed that in article 588 entitled Planet X Will Turn Earth into a Superheated Inferno. This is what Venus's atmosphere is doing. Venus has a very dense atmosphere, which it may have gained through interaction with the Planet X system. Venus is closer to the Sun than Earth, and therefore has a higher electric and gravitational potential than the Earth, and its dense atmosphere will cause it to emit a lot of radiation from infrared to X-ray. This is why Venus is so hot. Venus is almost a star. And now as Earth's electron levels move down toward the denser parts of its atmosphere, and also as a result of the increased Planet X debris in its atmosphere, the same thing will happen to Earth. Earth will, however, most likely not remain like Venus, as it will start losing outer layers as its gravitational energy continues to drop. So in conclusion, due to the Planet X system, which is absorbing its energy and causing the electron levels in the atmosphere to drop, at the same time that more and more stellar cores and their debris are entering the atmosphere, the Earth's atmosphere is emitting more and more radiation and heating up, so that Earth is becoming like Venus. And these are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.